Welcome everyone. This is a continuation of the Orange County R user group RSelenium webinar. Yesterday I didn't get a chance to finish the JavaScript example from the advanced operation section. Also, there was two questions. One of the questions was how do you save a screenshot using RSelenium? The second question was how do you use a Google Chrome profile when you're initiating a Google Chrome browser using RSelenium. I wanted to elaborate further on those two questions. So firstly, looking at the JavaScript example, it's from the D3 network package. It's a nice package for creating interactive network graphs from R. It uses the D3.js library from JavaScript. Recently it added support for interactive network graphs within your Shiny application, so I thought it was a great opportunity to showcase one of the examples from the D3 network package. So Christopher Gandrud is the author of the D3 network package, and he's got a GitHub page where you can run an example of a forced network graph. So what we're going to do now is just to open a second R which will run that example for us. So you can see we have this run GitHub function from Shiny, which takes a GitHub repository and a GitHub author, and then we can give it a argument port. We're going to run it on port 5678 just so it's nice and easy to remember. Hopefully now we should see that Shiny app pop up on our browser. So you can see on the local host on port 5678 there's now a Shiny app running, and it's this Shiny application from the D3 network package. So we're just waiting for the D3.js library to load up. So it's a nice little example showing this network graph, and we can pick the network graph up and move it around. So it's quite a fun example. I thought the motivation behind my JavaScript example would be, what if we saw this nice web application and we wanted to get this data back into R? How would we go about doing that? So I thought we'd open Firebug and have a look at the HTML source behind this page. It's fairly typical of a Shiny application. We can see it's using Twitter Bootstrap. There's a span 4 and a span 8. The plot has an ID of network plot. There's two scripts. There's the D3.js library being called, and there's this second bespoke script. And then the data itself is actually in the form of SVG. Now, technically, we could just retrieve that SVG and try to recover that data using R. I suspect there's an easier way, though. If we look at the JavaScript source, we can see that there is a links object being defined and a nodes object being defined. So let's move back to our RStudio IDE. Now, I've already opened a Firefox, so let's just navigate to that local host. So that's HTTP 127.0.0.1 on port 5678. I said there was two JavaScript objects we were interested in, nodes and links. Now, the remote driver class has an execute script function and an execute async script function. Both these scripts allow you to run JavaScript on the page you're currently navigated to. So let's just run a very simple bit of JavaScript. We're going to return nodes and see what happens. So there was this object nodes in the JavaScript. Let's return it and see what it gives us. And you can see it's as simple as that to get the JavaScript out of the web page with RSelenium. We just returned the nodes, and you can see it's quite a simple. So let's just nodes gets the output from the execute script function. And let's just take a look at the first. It's returning as a list, so you can see it's quite straightforward. So we've already got all that data, and it sort of looks like we could just row bind that together. So if we said do call rbind .data frame, fingers crossed, there you go. That's the nodes data coming straight back at us. So it's as simple as that, really, to get the data back into R from the JavaScript. There was that second variable that we were interested in, the links. So let's just say the links variable is a bit more complicated. It's actually as simple as return links if you're using the Firefox browser. Other browsers will crash if you try to do this. So we're not going to return that. We're actually going to return a stringified version of the object. So we're going to convert it to JSON using a JavaScript function called json.stringify, and that's actually going to return us this JSON object. So and we're going to assign that to a variable called JSON data. So this is our links object from the dnetwork example. Now let's further convert that. In the rjson.io library, there's a from JSON function, and that will convert JSON back into an R list. And then we can take a look at the first value of that, and we can see that we have 3 elements: source, target, and value. Value is atomic by the looks of it, and the other 2 elements, source and target, are lists. So let's just say we were interested in the source data from this links object. So how would we get at that? Well, we'd have to apply the app data. So let me just copy that to my script. And like I was saying, if we wanted to get at the source data, we'd have to work on each element of our list, and we'd select it, and we'd want the element which was named source. So that would be called our source data. Okay, so how does that look? If we look at the first element, you can see now we've separated the source data from the target and the value element. So quite straightforward. Now we might just be able to row bind that all by itself. Let's just have a quick look and see if it's relatively consistent with regards to its names. And it is. So to get that data back into a data frame would then just be as simple as using do call again. So we'd row bind by data frame source data, and let's have a look at that. It's probably a bit bigger, so we're just going to look at the head, and there you go. So quite a nice little example there of how we'd inject JavaScript into a web page with the RSelenium package. So that was my JavaScript example. I hope you liked it.